All right, let's get into it. You've probably seen the periodic table a million times, right? Hanging on a classroom wall. Well, behind that famous chart is this incredible story. I'm talking cosmic origins, total scientific chaos, and one of the most brilliant predictions in history. So today, we're going to crack the code of the periodic table.
And to get the full story, we have to start by looking up. I mean, way, way up. Because every single thing around us, you, me, the calcium in our bones, the oxygen we're breathing right now, all of it is made from elements that were forged in the heart of stars. You're looking at the birthplace of matter right here. These are the building blocks of, well, literally everything.
So think about it like this. The universe gave us all the ingredients, but it was up to us to create the recipe book. Or, you know what? A map is probably a better way to put it. We needed a map for all of matter, something to show us how it all fits together. And the thing is, this map wasn't just found. It had to be invented.
And it's a pretty weird-looking map, isn't it? I mean, that odd shape with all its weird blocks and towers, that's not random. Nope. It's a design that holds a really deep secret about how our entire universe is structured. So let's figure out how it got that way.
Okay, so for our story, we've got to go back in time. We're talking the mid-1800s, and for chemists, it was a time of, well, total and utter confusion. See, they were discovering new elements left and right, which sounds great, but instead of celebrating, they were just overwhelmed.
Yeah, get this. By 1860, chemists had found over 60 different elements. And you'd think, wow, that's great news, right? More data should mean more progress. But it was actually a huge problem. It was kind of like having 60 puzzle pieces thrown on a table, but you have no idea what the final picture is even supposed to look like.
And here's why it was just so chaotic. Imagine you're trying to build something with a team, but every single person is using a different ruler. That's exactly what chemistry was like back then. Scientists were all using different atomic masses for the very same elements. It led to complete confusion. It was basically impossible for one chemist to understand another's results. The whole field of chemistry was just stuck.
But then, a breakthrough. In September of 1860, the world's top chemists all got together in Karlsruhe, Germany. They had one mission: sort this mess out. And at that meeting, an Italian chemist named Stanislao Cannizzaro stood up and presented a standardized, reliable way to measure atomic mass. Suddenly, for the very first time, everyone was speaking the same language. And that one meeting, it kicked off a whole new hunt for a hidden pattern in the elements.
And that hunt brings us to the hero of our story, a Russian chemist named Dmitry Mendeleev. He heard about these new standardized masses from that conference, and it sparked an idea that was part game, part absolute genius. So Mendeleev was actually trying to write a chemistry textbook, and he was just desperate for a logical way to organize all the elements. He was convinced there had to be some kind of fundamental rule. He famously said that he believed the properties of the elements are in periodic dependence upon their atomic weights. So to find that rule, he basically made himself a deck of chemical flashcards.
Yep, just like this. On each card, he wrote an element's name, its brand new standardized atomic mass, and its key properties. And then he just started playing with them. He'd shuffle them, sort them, lay them out over and over again, almost like a game of chemical solitaire. He was just hunting for a pattern, any hidden rule he could find.
And you know what? He found one. He realized that when he lined the elements up in order of their atomic mass, certain chemical properties started to repeat over and over at regular intervals. That repeating pattern is exactly what we mean by periodic. It's like how the seasons repeat every year, or the phases of the moon repeat every month. It's a predictable cycle, and Mendeleev was the first to realize the elements had a cycle too.
Okay, so arranging the elements he knew about, that was clever. But what Mendeleev did next, that's what separates a good idea from a stroke of pure, unadulterated genius. He trusted his patterns so completely that he was willing to bet his entire reputation on it.
Here it is. This is his first ever published table from 1869. Now, it definitely looks a little different from the one we're used to, right? For one thing, it's organized vertically. But the core idea, the really brilliant part, it's all right here. Grouping elements with similar properties into families.
And here's the crucial part. Mendeleev realized the pattern of chemical properties was more important than just blindly following the numerical order. For instance, look at tellurium and iodine. Tellurium has a mass of 128 and iodine is 127. So iodine should come first, right? Nope. He swapped them. He deliberately broke his own rule just so iodine would line up with its chemical family, elements like fluorine and chlorine. He knew the properties were more important than the raw numbers.
But his real masterstroke? The truly bold move? He left empty spaces in his table. He had gaps, and he didn't see them as mistakes or flaws. He saw them as predictions. They were placeholders for elements that he was certain existed. They just hadn't been discovered yet. I mean, the confidence. He literally put question marks right there on the chart where these new elements should go.
And guess what? He was absolutely right. Within just 15 years, by 1886, all three of the elements he made space for, gallium, scandium, and germanium, had been discovered. And the craziest part? Their properties were a near-perfect match for what he had predicted. This was the smoking gun. This was the proof. His map didn't just organize what we already knew, it could actually predict parts of the world we hadn't even seen yet.
So Mendelev's table was a total triumph, a game changer. But for all its amazing predictive power, there was still one huge, fundamental question it couldn't answer. It was the final secret, the last piece of the puzzle that would make everything snap perfectly into place. And the question was, why? Why was it periodic? Why did the whole thing even work? Mendeleev knew that his pattern was real, but he had no idea what the underlying reason was. Turns out the real key wasn't atomic mass after all. It was something deeper, something way more fundamental about the very nature of the atom. That final answer came decades later, thanks to an English physicist named Henry Moseley. He's the one who finally cracked the code. And he discovered that the true organizing principle of the elements isn't their mass, it's their atomic number. And the atomic number is simply the number of protons in an atom's nucleus. That's it. That's the one thing that defines what an element is.
And this was the ultimate answer. See, the number of protons determines the number of electrons, and it's those electrons and how they're arranged that control all of an element's chemical behavior, how it bonds, how it reacts, the whole shebang. That was the why behind Mendeleev's pattern. The atomic number provided this beautiful, simple logic for the entire table. It even fixed those few little swaps Mendeleev had to make, like with tellurium and iodine. It all just worked.
And that brings us right back to the beginning, full circle. From the raw, chaotic stardust forged in the hearts of supernovas to this unbelievably elegant and powerful map of all known matter. The periodic table really isn't just a chart on a wall. It's the story of our quest to find order and meaning in a seemingly chaotic universe.
So in the end, what this whole story really shows us is that our universe isn't random at all. At its most fundamental level, it's governed by these beautiful, elegant, predictable patterns. It really makes you wonder, doesn't it? What other incredible patterns are still out there just waiting for the next person with, I don't know, a deck of cards and a brilliant idea to come along and find them?